Hello friends, in this session we are going to talk about how to find the direction of torque. Let's begin. Yes, now we have already thought of that torque which is there, it is produced in both motor as well as in generator. Right. So now you will ask me, sir, but then how will you differentiate between a generator and the motor? Let's see. For example, if the torque is in this particular direction and if the speed, or we can say the direction of rotation, is in the same direction, that is, let us say omega, if it is in the same direction, then we call that particular machine as motor, right? And if the direction of the rotation is in opposite direction like this, then it is called as a generator. These are the basics which we have already learned, right? Now we will be discussing about how to find the direction of torque developed. Yes, basically in this session we are going to find the direction of torque. Torque developed, right? Right. So now we know that torque will be there in case of motor as well as it will be there in case of generator. But whenever torque is produced, we call it as a motoring action. But now students say that, sir, but torque is produced in motor as well as in case of generator, then what is the reason that we are saying whenever it is torque developed, we say that it is a motoring action? What is the reason, sir? Reason is very simple. See here. Torque is produced in both generator as well as in case of motor, but the basic principle for the torque developed will be called as motoring action. Means, again, see here. Torque is developed in case of motor and hence it is called as motoring action. Hence it is called as motoring action, and motoring action happens in both generator as well as in motor. Like, example, in the previous session we had talked about the direction of induced EMF, right? And then there we said that induced EMF is nothing but generator action, if you all remember this, right? But now see, induced EMF is there in case of generator as well as it is there in case of motor, but still we called it as a generator action. We said that induced EMF will be there in case of generator and it is called as generator action, and generator action will be there in both generator as well as motor. Simple concept. Now let us move forward. Yes, see here, case 1. Now let us consider a stator like this. If it is a stator, we need to have a bullseye, right? Let us say this is the stator. Now what I'm saying is, this stator has, let us say, randomly we are taking 2 poles. Randomly, you can take N here, S here, you can take S there, and down, there is no problem. Whatever you take. For example, I am considering this as N and this is S. Right? Now we know that the flux direction will be like this. Is it right? 100%. Now I am assuming one conductor here like this, right? Now see here, we are discussing about motoring action, right? Which means we are not going to rotate the conductor, rather we are going to inject some current in it. Let us say this is the current, right? Dot current. Now according to right hand thumb rule, what did we know? That whenever there is electric current, there is going to be flux set by Oersted, but the direction will be given by what? Right hand thumb rule. So if this is my thumb, right? it is out of the board. So this becomes out of the board, and direction of flux will be like this, which means this is the direction of the flux. Outward current, this is the direction of flux, right? Now see here, what is happening here? This particular flux, which is nothing but the rotor flux, is getting opposed by stator flux here, which means here the net flux will be 0. Now, what is happening here? If you see, this flux red is aiding, or it is helping the stator flux blue. That is the reason what will happen, flux will get stretched here like this, and it will complete the path, right? Flux will get stretched like this. Now, we have already studied that the direction in which the rubber band or the flux lines are stretched, torque will be produced in its opposite direction. Already discussed, right? So here if we see, rubber band is stretched from right to left, which means torque will be produced from left to right like this. Is it clear? Right? Now, what I am doing is, I am, let us say, holding the rotor like this. So yeah, here our case 1 ends. What were we intending to know is, we had to find out the direction of the torque developed. This is the conductor, outgoing current is there, flux will be there, interaction between the fluxes is there here, right? Due to this interaction of fluxes, this flux, rather than moving in straight direction, it is going to move in this direction now. Means the flux lines are going to be stretched. The direction in which flux lines are getting stretched, in the opposite direction will be the torque. Now you will tell me, sir, you are writing here torque and we are saying but basically it has to be force, right? Because when we talk about torque, it comes under rotational motion, right? But still you are saying torque, it's okay. You can say it as a force, or you can say anything, but it is basically force or torque. Basically understanding the concept is important. Yes. Now in case 2, what are we going to do? In case 2 also same, we are going to have the stator like this. Why it is stator? Because here is going to be the bullseye. This is, let us say, north pole. This is, let us say, south pole. And here we know that flux line direction will be from north to south like this. Already discussed. Now if let us assume one rotor here, right, and on the rotor there are 2 conductors like this, and let me assume that these particular conductors are having some current in it. Let us say this is dot and this is cross. So now see here, what is going to happen? This is dot, this is cross, which means current is entering from cross like this, and it is going to come out from top like this. This is out of the board, this is into the board. This is into the board current, and this is going to be out of the board. That is the reason. What are we going to get? There will be flux lines like this. Flux lines will be produced in this direction. Am I right? Say here one more time. This goes in, this is out. If, for example, I am sitting in the air gap. I am sitting in the air gap. What will I see? From this part of the iron, basically whether it is stator or it is rotor, it will be made up of what? Iron only. So if I see here, if I am sitting here in this air gap, what is going to happen? See, I will see that this particular flux is going to come out of the iron piece. This is the iron piece. Flux lines are in this particular direction. Like this, flux are coming, which means that here flux lines are coming outside, outgoing from the iron piece. That is the reason this is going to be north pole of the rotor, NR. And of course, in this direction, what is going to happen? See, this flux will go out like this, come back to pavilion in this way, which means here incoming of the flux will be there to the iron path. That is the reason here south pole will be produced, right? Now if you see here, this is south, this is north, they will get attracted, attraction, north and south, it will get attracted, which means torque is produced in this direction, right? Now student will say, sir, the stretched rubber band, this is there, what should we think of first? See here, very important. Why? Because here in this case we were discussing about the stretched rubber band, and you will say immediately that, sir, initial case it was about the stretched rubber band. In this particular case you are not considering stretched rubber band, rather you are directly naming the poles here and doing the things. Okay, no problem. We will try to verify the same thing in terms of stretched rubber band. Let's see. Yes, see here. Do you agree that this particular current is dot current? Now, whenever there is going to be current, there is going to be flux, and the direction of the flux will be given by right hand thumb rule. So if we see here, this is going to be outward like this, direction of flux is this, which means flux here will be like this, up and here down. Do you agree? Right. Here if you see, cross is there. If it is crossed, what is going to happen with the flux? See, this is cross into the board. Flux will be like this, which means flux direction is going to be like this. This is down, up. Perfect. Now see here. Here if you see in this particular area, what is happening? This rotor flux and the stator flux are opposing each other, which means flux here has to be 0, approximately 0. If you see here, what is happening? Rotor flux is in this direction, stator flux is also in the same direction, which means flux is going to be aiding there, which means this flux has to come like this, right? This flux has to come like this. Now see here, what is happening? This is the south pole. Flux lines will be coming like this. If you see, it is the south pole. Stator flux line will be coming like this, right? Now stator flux lines are like this. See here, these are the rotor flux lines. Rotor flux lines in this particular area are opposing each other, right? And in this particular area, rotor flux lines are aiding the stator flux lines, which means it is going to come like this. Stretching will happen like this, right? From the previous discussions, we already know that if the stretching is in, let us say, this direction, then torque is going to be in the opposite direction. If the stretching is in, let us say, this direction, then torque is going to be in the opposite direction. Already we have discussed. So here if you see, stretching is in this direction, which means torque is going to be this direction. Here if you see, what is going to happen? Stretching is in that direction, which means torque is in this direction, right? Which means torque is going to be this direction. Net torque will be in same direction. So basically, if you find the poles of the rotor, or you think of in terms of a stretched rubber band, results are going to be same. Now let us see case number 3. Now let me have a bullseye here, which means this is going to be the stator, right? Now let us say there are 2 conductors here on the stator. Let me draw it again. These 2 are, let us say, the stator conductors. Now what I am doing from here, now I am going to inject some current here like this. This is, let us say, cross, and this is, let us say, dot, right? And now I have a rotor like this. And let us say this is N pole of the rotor and this is S pole of the rotor. Right. Now, yes, one thing which I actually forgot to tell, it was what? Whenever we are talking about the direction of torque developed, it is nothing but electromagnetic torque only. We need to understand this. Whenever we think of the direction of torque, we are talking about the direction of electromagnetic torque only in general. We are not at all talking about the reluctance torque. Reason is very simple, because in case of reluctance torque, we know that stator is there, rotor is there, stator is there, rotor is there like this, and the reluctance torque is only because of the position of the rotor, which means there are no rotor poles induced in the machine which is having reluctance torque. Very important. Here if you see, there are no rotor poles. Rather, the torque will be happening only and only because of position of the rotor. Already we have discussed. Now see here. This is the north pole, which means flux is going to be in this direction. This is south pole, which means flux are going to be incoming to the rotor. This is the rotor which already has some or the other winding. Let us say this is a rotor which is having, let us say, some winding like this. It is a rotor which is having, let us say, some winding like this. I current is flowing in the rotor, because of it this is the current which is going. Right hand thumb rule will give me direction of flux. Flux will be upward, hence it becomes N, it becomes S. Now this is a stator conductor. What are we expected to find? We are expected to find the direction of torque developed. Now in which particular direction will the torque be developed? Let us see. You tell me, we already have the rotor poles. We don't have stator poles. Why we don't have? See, already currents are given. This is cross and this is dot, which means by using right hand thumb rule, we will be able to find the direction of the flux. Now if we observe here, if we apply right hand thumb rule, what is going to happen? See, this is cross into the board, this is dot out of the board. If it goes in out of the board, this is going to be the direction of flux, which means this is going to be the direction of flux. Right? This is going to be, this is cross, this is dot, direction of flux will be from right to left like this. Now I am sitting in the air gap. I am sitting here in the air gap. What will I see? In the stator iron piece, for this particular piece of the stator, flux is incoming, which means this becomes south pole of stator. This becomes south pole of stator. Whereas if you see here, from this particular part of the stator, the flux lines are outgoing. From this iron piece of stator, flux lines are outgoing, which means this is going to become north pole of the stator. Is that correct? Yes. Now, what does this mean? If you see here, this is N pole. Now, if you see here, this is north pole, this is north pole, they are going to repel each other. This is south pole and this is south pole, they are going to repel each other. This is north pole and this is south pole, which means they are going to attract. This is south pole and this is north pole, which means they are going to attract. Now here, by no means I am saying that this particular machine is rotating in the same direction. I am not saying that this is the direction of rotation. I am telling this one more time. I am not at all saying that the rotor is going to rotate in this fashion. I am not at all saying it. I am just saying that the direction of the torque developed is nothing but like this in this particular case. Right? Yes. Now if we try to understand the same thing in terms of stretched magnetic field, let us see how it happens. Now see here, this is cross, which means flux is going to be like this. Flux is going to be like this. This is dot, which means flux is going to be like this. Right? If you see here, what is happening? In this particular region, the flux is aiding each other. See, rotor flux is also same direction, stator flux is also same direction, which means here it is aiding. Here if you see that, it is opposing. So basically what will happen? Lines will be stretched like this. These flux lines will be stretched in this particular fashion. Here they are opposing, so here flux is 0. Here they are aiding, that is the reason flux lines are going to stretch. Here if you see, what is going to happen? In this particular area, flux lines are opposing each other. Whereas here if you see, this flux of the stator is upwards and rotor flux is also upwards, which means here the flux is going to go. So here the flux is going to move like this. Right, because here if you see, flux lines are aiding. Here if you see, flux lines are opposing. Aiding, that is the reason it is going to stretch this way. Now from the stretched rubber band point of view, we already know that force will be in the opposite direction to the direction of the stretching. It is stretched in this direction, which means force is going to be in this direction. This is stretched in that direction, which means force is going to be in this direction. Is it same? Can I say that again from this point of view also? Electromagnetic torque developed is nothing but clockwise. I am not saying that the machine is going to rotate in the same direction. I am just telling you that the torque developed is in this direction. I hope it is clear. Why? Because if the direction of rotation of my machine is in the same direction to the torque developed, means for example, omega, angular velocity, speed, right? If the speed of rotation is in the same direction to the torque, then it means it is going to be motor. If beyond this torque I am going to rotate in this direction, means torque is like this, still I am trying to rotate it in this direction, in the opposite direction to the torque, then it is generator. I know I am repeating the same things, but they are very, very important. It should get fit in your mind. Now, let us take another case. Yes, so now talking about case 4. What is going to happen in this case? Let us see. I am going to have a stator like this. Why it is a stator? Bullseye. Right. Now see here. I am going to take 2 conductors on the stator and I am going to assume cross and dot currents flowing in it. These are not voltages, these are currents. Remember that. I am injecting cross current here, dot current is coming out. Now by red means rotor, already we know convention. Now here I am assuming 2 conductors. Right. Now here also what I will do, I will inject some current, cross here, cross, and here I will allow this current dot. Right. Now what is happening? See, let us talk about the rotor flux first. There is what, see here we have cross, here we have dot current, which means current is flowing in this direction. Current is flowing in this direction like this, which means flux is like this. The moment flux is like this. Now it is a rotor, so rotor has to be shown with a shaft key. Right. Now direction is this way, flux direction, which means here if you see from here, if I am sitting here in the air gap, what do I see? From this iron portion of the rotor, flux is going to come out, which means this is going to be north pole, this becomes north pole and this becomes south pole. How? flux will go like this, come back to pavilion. Here it will enter into this space. It is going to be south pole. We know that. Now, how about the stator? Stator C. This is cross current. This is dot current. This is cross. That is cross, and this is dot current. Current entering there, coming out here, entering there, coming out there, which means flux is this way. Flux is going to be this way. What does this indicate? This indicates that here, if you see, this is the stator part, stator iron. If you observe the flux is incoming here, incoming to the iron piece, which means this is going to be south pole. Outgoing to the iron piece, here if you see, this is the iron piece of the stator. From here, flux is outgoing. The flux is outgoing, which means this is going to be north pole of the stator. North pole of stator, south pole of stator. Perfect. Now see here, what is happening? North will repel, south will repel. North will get attracted. South and north will get attracted here like this. And here if you see, north and south will get attracted. Now you tell me one thing. Will the stator rotate? No. Stator is going to be stationary. Rotor will only rotate. Now, see here what is happening. The torque developed will be how this south pole will get attracted towards the north pole, and this north pole will get attracted towards the south pole, which means direction of torque is this direction. Again, I am not at all saying that this particular machine's rotor is going to rotate in the anti-clockwise direction or not, because see here, I am only concerned about the direction of torque. I am not at all talking about the direction of rotation. Why? Because we know that if the direction of rotation is in the same direction, it is going to be motor. If it is going to be in opposite direction, it will be called as generator. Already we know that, right? Yes, thank you.